Hello. Yes! And welcome to our Objective 1.7 notes. Now, Objective 1.7 says I can perform operations, add, subtract, multiply, and composition with functions in function notation. So, today's notes, we're going to talk about how to do all of those and get some practice in, make sure we're good to go so that we have a really solid understanding of this objective. So, the function notation part is just really how it's written. So let's talk about how adding and subtracting is written. We'll see something like this, f plus g of x, or f minus g of x, okay? This is the same thing as just f of x plus g of x, or f of x minus g of x. So the order that we see inside these parentheses tells us the operation, and then the second set of parentheses tells us our input. So let's go ahead and try some examples here. So if I'm looking at letter A, f plus g of x, this is the same as f of x plus g of x. So all I need to do is substitute in f of x, which equals 2x squared minus 4x plus 5, and g of x, negative 5x squared plus x minus 7. So I will have 2x squared minus 4x plus 5 plus negative 5x squared, so we can throw that in parentheses to show that it's that negative, plus x minus 7. And I'm just going to combine like terms. So I have 2x squared plus negative 5x squared. That'll become negative 3x squared. I have negative 4x plus x. That'll become negative 3x. And then I have 5 minus 7. So 5 minus 7 will become negative 2. Now notice how when I did that, I crossed them off. That's just helping me make sure I utilize all my terms. You do not have to do that by any means. But that means my final answer, f plus g of x, equals negative 3x squared minus 3x minus 2. And there we go. All right, let's look at letter B, g minus f of x. So this is the same thing as g of x minus f of x. So g of x is negative 5x squared plus x minus 7 minus, I'm going to put all of f of x in parentheses to show that this negative is getting distributed. So 2x squared minus 4x plus 5. And then once again, we'll just combine our like terms. So we have negative 5x squared minus 2x squared, so that'll become negative 7x squared. We have x minus negative 4x. So I'm subtracting a negative, so that's the same as adding. So this will be x plus 4x. So this is going to become positive 5x. And then I have negative 7 minus 5. That's negative 12. So we have now found that g minus f of x equals negative 7x squared plus 5x minus 12. Now notice for A and B, our input was just x. We can have a different input. So let's look at what happens when that occurs. So let's look at letter C here. F minus g of negative 1. So this then becomes f of negative 1 minus g of negative 1. And there's two ways to approach this, really. One, we can do f minus g of x and then substitute in negative 1. Or we can find f of negative 1 and g of negative 1 and then subtract them. I like to do it that way. I think it's a little easier. So f of negative 1 is 2 times negative 1 squared minus 4 times negative 1 plus 5. So negative 1 squared will become 1, so this will become 2 times 1. Negative 4 times negative 1 is positive 4, and then plus 5. So this will become 2 plus 4 plus 5, so we can know that f of negative 1 equals 2 plus 4 is 6, 6 plus 5 is 11. Now we can do g of negative 1. And g of negative 1 equals negative 5 times negative 1 squared plus negative 1 minus 7. So negative 1 squared will become 1, so this will be negative 5 times 1, which is negative 5, plus negative 1 is minus 1, and then minus 7. So that means g of negative 1 equals negative 5 minus 1 is negative 6, and then negative 6 minus 7 is negative 13. So remember how up here f of negative 1 minus g of negative 1? Well, we now know that f of negative 1 is 11. G of negative 1 is negative 13. So 11 minus negative 13. That tells us that f minus g of negative 1 equals 11 plus 13 is 24. There we go. All right, let's try letter D together. So instead of just a number now, we're back to having an expression. So G plus F with the input of x minus 2. So I'm going to kind of be clever about this here. If I look up here, I know f plus g of x equals negative 3x squared minus 3x minus 2. I know addition doesn't matter which way I do it, right? G plus f is the same as f plus g. So I know that f plus g of x equals negative 3x squared minus 3x minus 2. Well, then let's figure out what this is with the input of x minus 2. So I'm going to have g plus f of x, just x, equals negative 3x squared minus 3x minus 2. Now let's plug in x minus 2 into this expression. So I'll have negative 3 times x minus 2 squared minus 3 times x minus 2, and then minus 2. So we'll have negative 3 times x minus 2 squared is x minus 2 times x minus 2. And then distribute our negative 3, so we'll have negative 3x plus 6, and then minus 2. Multiply this out here. Let's give ourselves a little more space. So I'll have negative 3 times the quantity, x squared minus 4x plus 4, minus 3x, and then 6 minus 2 is 4. Distribute our negative 3, so negative 3x squared plus 12x minus 12 minus 3x plus 4. Combine our like terms. So I'll have negative 3x squared. 12x minus 3x is 9x. Negative 12 plus 4 is negative 8. So I'm left with g plus f of x minus 2 equals negative 3x squared plus 9x minus 8. And there we go. All right, and that's adding and subtracting in a nutshell. All right. So the notation, remember to write it out, and then using the equations they give us for those functions, we can do all sorts of things with them. There's addition and subtraction. Now let's talk about multiplication. So multiplying functions, f times g of x, this is the same thing as f of x times g of x. All right. Now, again, depending on the input, there's different ways we can approach this. Same idea applies. So let's look at letter A here. They give us three functions, j of x, k of x, and m of x. This first one is j times k of x. So that would be j of x times k of x. So j of x is 4x minus 2. K of x is 2x squared plus 1. Now I'm just going to multiply this out. So 4x times 2x squared will be 8x to the third. Negative 2 times 2x squared will become negative 4x squared. 4x times 1 is 4x. And negative 2 times 1 is negative 2. Now, no like terms to combine here. You might say, hey, Mr. Carter, I see that I can divide all of these things by 2. Should I do that? The answer is no, don't do it. All right, do not do that. We're just trying to simplify. We're not trying to factor or anything. So my final answer, I would say j times k of x equals 8x to the third minus 4x squared plus 4x, and then minus 2. There we go. Let's look at letter B here. M times k of x. So this is m of x times k of x. And we know that m of x is 6x plus 5. We know that k of x is 2x squared plus 1. So let's multiply these out. 6x times 2x squared would be 12x to the third. 5 times 2x squared is 10x squared. 6x times 1 is 6x, and 5 times 1 is 5. So I have m times k of x equals, no like terms to combine, so we can just rewrite our answer here, 10x squared plus 6x plus 5. And there we go. All right, let's look at letter C, m times j of x minus 3. Okay, so here is an example that we should definitely look at. So this is going to be m of x minus 3 times j of x minus 3. So what I'm going to do first is I'm going to simplify m and j. So m of x minus 3 equals 6 times x minus 3 plus 5. All right, so that's 6x minus 18 plus 5, and that'll be 6x minus 13. So there's m of x minus 3. J of x minus 3, now j of x is 4x minus 2, so j of x minus 3 will be 4 times x minus 3, and then minus 2. So when I do this, I'll have 4x minus 12, and then minus 2, 4x minus 14. So here now, 6x minus 13 and 4x minus 14, that is m of x minus 3 and j of x minus 3. Those are the things I'm going to be multiplying together. Hope you aren't afraid of some big numbers. Let's see how it goes. So we have 6x minus 13 times 4x minus 14. All right, 6x times 4x is 24x squared. 6x times negative 14 is going to give me negative 84x. 6 times 14 is 84. And then negative 13 times 4x is going to give me negative 52x, because negative 13 times 4 is negative 52. And then negative 13 times negative 14, that's going to give me positive 182. All right, combine our like terms, so we'll have 24x squared minus 100, and let's see, 84 plus 50 would be 134, so minus 136x plus 182. And that, my friends, is m times j of x minus 3, 24x squared, minus 136x plus 182. Fun, fun, fun. That was a good one. All right, letter D, last one of these multiplying, k times j of 2. So this is k of 2 times j of 2. All right, let's check this out. So k of 2 is what I need to find first. Now, of course, you could do k times j of x and then substitute that in, kind of like we did up with our addition and subtraction. And we do have that right here. J times k is the same as k times j. So we could just plug in 2 to this 8x to the third minus 4x squared plus 4x minus 2. But I want to show the full process for this one. Or an alternative where we're going to find k of 2 and j of 2 first. So k of 2 will equal 2 times 2 squared plus 1. So that's 2 times 4 plus 1. That tells me that k of 2 is going to equal 9. Now j of 2, on the other hand, is 4 times 2 minus 2. Give me some more space here. 4 times 2 is 8 minus 2. So that tells me that j of 2 is 6. So k of 2 times j of 2 is just 9 times 6, which equals 54. So I can say that k times j of 2 equals 54. All right. Hopefully we're feeling confident with addition, subtraction, and multiplication. We have one more that we're going to do, and that's composition. Now, composition is a little different. We might have seen this before, and we would say this is f of g of x. So that, again, if you see this, some people call it fog. That is not the mathematical correct term. This is f of g of x. And what that means is I am going to take g of x and put it, whatever it is, into f. Now, g of f of x is this example here, and that would be written like so. I'm going to take f of x and plug it into g. All right, let's try some examples to see what we're talking about. So f of g of x is the same as f of g of x. So here's my example. G of x is 3x minus 4. So I'm going to plug that in for this parenthesis. So I will have f of 3x minus 4. Okay, now from here, I'm going to put 3x minus 4 in for f. So I will end up having, let's see, so f of 3x minus 4 equals 3x minus 4 squared minus 2 times 3x minus 4 plus 1. I'm definitely writing over into b here. I don't want to be doing that. Okay, so 3x minus 4 squared, so I'm going to be multiplying that out. 3x minus 4 times 3x minus 4. I can distribute this negative 2. Negative 2 times 3x is negative 6x. Negative 2 times negative 4 will become positive 8 and then plus 1. Okay, let's multiply this out here. So 3x times 3x is 9x squared. 3x times negative 4 is negative 12x, and that will happen twice. One for the outside and one for the inside here. And then negative 4 times negative 4 is 16. And we'll subtract 6x, and 8 plus 1 is 9. And then we can just combine our like terms. So we can say that f of g of x equals 9x squared. We have negative 12x minus 12x, so that will be negative 24x, and then minus another 6x, so that will be negative 30x. 16 plus 9 is 25. And there we go for f of g of x. Now notice on this one my input was x. What if it's a number? Well, let's try g of f of 3. So the first thing I'm going to have to find here is f of 3. So I will find f of 3. Let's try to split this up a bit. F of 3 equals, this will be 3 squared minus 2 times 3 plus 1. So 3 squared is 9. Negative 2 times 3 is negative 6 plus 1. 9 minus 6 is 3. 3 plus 1 is 4. So f of 3 equals 4. So since I know now f of 3 is 4, I need to find g of 4. So g of 4 is 3 times 4 minus 4, which is 12 minus 4, which is 8. So now I can say pretty confidently that g of f of 3 equals 8. All right, last one, g of 2x plus 1. Now you might be thinking, it's kind of weird to have g of g, but it can happen. This is just saying we're going to take g of 2x plus 1 and plug it into g again. All right, so first thing I need to find is g of 2x plus 1. So g of 2x plus 1 equals 3 times 2x plus 1 minus 4. So distribute the 3. 3 times 2x is 6x. 3 times 1 is 3, and then minus 4. 3 minus 4 is negative 1, so 6x minus 1 is g of 2x plus 1. So now I need to find g of 6x minus 1, since 6x minus 1 is g of 2x plus 1, and that's what I'm working on up here. So g of 6x minus 1, so now I will have 3 times 6x minus 1 minus 4. Notice I'm plugging that in for this x here. So 3 times 6x is 18x. 3 times negative 1, I don't know what's happening. Sorry about that, something just popped up. 3 times 6x is 18x. 3 times -1 is -3, and then we have -4 there. So 18x minus 3 minus 4, that would become 18x minus 7. So out of all of this, we can say that g of 2x plus 1 equals 18x minus 7. There we go. All right, hopefully we're feeling pretty confident about adding, subtracting, multiplying, and composing functions. If you're feeling good about it, go ahead and look at those practice problems, get to work. If not, and you want to do some more, go ahead and check out the sample problems video, and we can get some more experience together. All right, this is Mr. Carter signing off. I'll see you next time.